The ocean, covering more than 70% of Earth's surface, is the largest world humanity has yet to fully explore. It is a place of mysterious beauty, but also a brutal battlefield for survival. Join us as we dive deep into the ocean, where the largest creatures and the most fearsome predators on the planet continue to exist. The 5 great oceans cover our blue planet, each with its own climate, ecosystem, and unique inhabitants. From warm tropical waters to frozen polar seas, life has found extraordinary ways to adapt and survive. Our journey begins with the largest ocean on Earth. The Pacific Ocean covers more than 64 million square miles, making it the largest and deepest ocean on Earth. Beneath its surface lies the Mariana Trench, nearly 36,000 feet deep, one of the darkest and most mysterious places on the planet. The surrounding ring of fire creates earthquakes and volcanoes, but it also gives birth to new environments where countless species can thrive. This is the blue whale, the largest animal ever to exist on Earth, even surpassing the greatest dinosaurs of the past. This body can reach nearly 30 meters in length, with a heart as large as a small car. A creature of unimaginable size, yet it survives by feeding on some of the smallest organisms in the ocean. Every day, blue whales can consume tons of krill to sustain their enormous bodies. It is one of nature's greatest paradoxes. The largest animal survives on the smallest creatures. This is a remarkable example of the delicate balance within the ocean food chain. Blue whales communicate through low-frequency sounds that can travel hundreds of miles across the ocean. They undertake migrations spanning thousands of kilometers, traveling from cold, food-rich waters to warmer breeding grounds. A remarkable journey repeated year after year. Dolphins are considered among the most intelligent creatures in the ocean. They can reach swimming speeds of up to 31 miles per hour, moving like silver arrows beneath the waves. Their remarkable intelligence makes them some of the ocean's most skilled hunters. Dolphins use echolocation to locate prey and communicate with one another in the darkness of the ocean. They hunt in groups, working together to surround schools of fish and squid with precision. Remarkably, each individual has its own unique identifying sound, almost like a personal name. Among vibrant coral reefs, clownfish live in a symbiotic relationship with sea anemones, a partnership that seems dangerous but is truly harmonious. A special mucus layer protects them from the anemone's toxins. In return, clownfish help defend the anemone from other predators. One of the most fascinating traits of clownfish is their ability to change sex when necessary. When the dominant female of the group dies, a male transforms to take her place. This is one of the most unique survival strategies found in the natural world. The hawksbill turtle is known as the silent guardian of coral reefs. It feeds on sponges and small organisms, preventing them from growing excessively and damaging coral ecosystems. Its role may seem small, but it is essential for maintaining the balance of marine environments. As the Pacific Ocean meets Antarctica, the world transforms into a completely different landscape. Ice and snow cover everything, while temperatures drop to some of the harshest levels on Earth. Yet even here, life continues to survive in extraordinary ways. Penguins cannot fly through the sky, but they have evolved to fly beneath the ocean waves. With wings transformed into powerful flippers, they can dive more than 1,600 feet in search of food. Their waterproof feathers and thick layer of fat help them stay warm in the freezing Antarctic cold. In this frozen and unforgiving environment, penguins hunt for krill, small fish, and squid to support themselves and their chicks. Every hunt is a true struggle for survival. These remarkable adaptations have allowed them to endure for millions of years. Seals possess a thick layer of blubber that protects their bodies from the extreme cold of Antarctica. Their sensitive whiskers can detect the movement of prey even in dark waters. They are capable of diving nearly 1,900 feet deep in search of food. On floating ice, mother seals nurse their pups with milk rich in fat, helping them quickly build the insulating layer needed for survival. This critical stage determines the future of the next generation. The bond between mother and young in the frozen wilderness is one of nature's most touching scenes. The killer whale, or orca, is the dominant predator of the Southern Ocean. They live in tightly organized family groups connected across generations. Their extraordinary intelligence makes them master strategists of the marine world. One of the most astonishing hunting techniques of orcas is creating waves to knock prey off floating ice. This skill is passed down through generations and requires perfect coordination between members of the pod. Their ability to cooperate makes them one of the most intelligent predators in the ocean. Humpback whales use a unique hunting technique known as the bubble net. They swim in circles, releasing streams of bubbles to surround and compress schools of fish into a tight group. It is one of the most sophisticated forms of cooperative hunting in the animal kingdom. Humpback whales are also famous for their songs, which can last for tens of minutes. These sounds travel hundreds of kilometers through the ocean and are considered a complex form of communication. Scientists are still trying to uncover the true meaning behind these mysterious underwater melodies. The Atlantic Ocean is the second largest ocean in the world and plays a crucial role in regulating the global climate. The Gulf Stream carries warm water from tropical regions toward the north, influencing the weather patterns of an entire continent. It is also home to many unique marine species. Green sea turtles begin their lives on beaches, hatching from eggs buried beneath the sand. Moments after birth, they must make their own way toward the vast and dangerous ocean. It is their first journey of survival and one of the greatest challenges they will ever face. Green sea turtles can migrate thousands of kilometers across oceans throughout their lifetime. Remarkably, after decades of wandering through the seas, they can return to the exact place where they were born to reproduce. This navigation ability is considered one of nature's most extraordinary examples of biological memory. The great white shark is one of the most feared predators in the ocean. Reaching lengths of more than 6 meters, it possesses incredible strength and speed. Its ability to detect electrical signals allows it to locate prey even when they are hidden beneath the sand. Great white sharks hunt seals, sea lions, and large fish through powerful ambush tactics from below. They approach silently before launching a sudden attack with incredible speed. It is one of the most dramatic and intense hunting scenes in the ocean world. Jellyfish have existed on Earth for more than 500 million years, long before dinosaurs appeared. Without a brain, heart, or bones, they have survived through a simple yet highly effective body structure. Jellyfish play an important role in the food chain by helping regulate plankton populations. The Arctic Ocean is the smallest ocean, yet it has a tremendous influence on global climate. It is a world of magical auroras and endless winters. Only creatures with extraordinary cold weather adaptations can survive in this frozen realm. Polar bears are among the largest land carnivores on Earth. Their white fur provides perfect camouflage across the icy landscape while also offering excellent insulation. A thick layer of fat beneath their skin helps them survive some of the harshest cold conditions on the planet. Polar bears possess an incredibly powerful sense of smell, allowing them to detect seals hidden beneath thick ice from great distances. They can patiently wait for hours beside a breathing hole before making their final strike. This is a remarkable demonstration of patience and survival intelligence. Walruses possess distinctive long tusks, which they use to pull their heavy bodies onto the ice and compete with others. Their thick layer of blubber keeps them warm in freezing waters throughout the year. They mainly feed on clams, mussels, and other bottom-dwelling marine creatures. Walruses often gather in large groups to protect one another from dangerous predators. This cooperation is an important survival strategy in the harsh polar environment. Each individual contributes to the safety and survival of the entire community. Sea lions are highly social predators that often live along rocky shores and coastal islands. They hunt fish, squid, and crustaceans in coordinated groups. During breeding season, males compete fiercely to defend territory and gain mating rights. The Indian Ocean is known for its warm waters throughout the year, vibrant coral reefs, and powerful currents influenced by seasonal monsoon winds. It is a tropical paradise for countless unique marine species. The biodiversity found here is among the richest in the world. The whale shark is the largest fish still living on Earth, reaching nearly 12 meters in length. Despite its enormous and intimidating size, it is one of the gentlest creatures in the ocean. These peaceful giants pose no threat to humans. Whale sharks feed on plankton by filtering seawater through their specialized gills. Every day, they can filter thousands of liters of ocean water in search of tiny sources of nutrition. It is another example of nature's incredible rule. The largest creatures can survive on the smallest organisms. Manta rays can have a wingspan of more than 7 meters, moving gracefully as if they are flying beneath the ocean waves. They possess large brains and remarkable memory abilities compared to many other fish species. Manta rays are symbols of elegance and intelligence in the marine world. Lionfish display stunning beauty that captures attention among coral reefs. But behind this beauty are venomous spines used both for hunting and defense. They are a perfect example of nature's combination of beauty and biological weapons. But this magnificent ocean world is facing serious threats caused by human activities. Rising ocean temperatures are causing coral reefs around the world to bleach and gradually die. Ecosystems that were once full of color are slowly becoming barren. Rapid ice melting at both poles is changing important ocean currents around the planet. This directly affects global climate and the habitats of countless species. Polar bears and seals are gradually losing the environments they depend on for survival. Human plastic waste is gradually breaking down into microplastics that enter deep into the ocean food chain. Abandoned fishing nets become deadly traps for whales, sea turtles, and seabirds. Every year, millions of marine creatures suffer the consequences of these careless actions. These impacts threaten not only marine life but also human existence. The ocean regulates climate, provides food resources, and supports the oxygen cycle of our planet. When the ocean suffers, the entire Earth's ecosystem suffers as well. But there is still hope. Around the world, people are working to restore mangrove forests and seagrass meadows, the vital green lungs of the ocean. More marine protected areas are being established to safeguard the precious ecosystems that remain. International scientific cooperation is creating new solutions to protect the ocean sustainably. Environmental education helps younger generations better understand the incredible value of the seas. Every small action, when multiplied by millions of people, can create a powerful change. Little by little, conservation efforts are bringing positive changes to the ocean. Coral reefs are beginning to recover, and life is returning to places once damaged. This proves that nature has an incredible ability to heal when given the opportunity. From the giant blue whale to the gentle whale shark, From intelligent dolphins to powerful orcas, the ocean is a world of both wonder and struggle. It is the shared home of millions of species and a source of life for our entire planet. Protecting the ocean means protecting our own future. At the far end of Earth, a frozen continent waits in silence. 6 months of darkness are ending. The sun is returning. And with that light, life is preparing to explode. This is the Antarctic summer, the shortest and most intense season on Earth. The sun does not set for many continuous weeks. Every creature uses every precious hour of light. The Southern Ocean surrounds this continent like a vast ecological ring. Cold currents lift nutrients from the deep ocean to the surface. That is what creates one of the richest marine environments on Earth. As temperatures rise slightly, the sea ice begins to retreat. Millions of square kilometers of open water are released within weeks. This is the opening signal for a vast food chain. Sunlight penetrates the cold water and triggers an explosion of phytoplankton. They are too small for the human eye to see, yet their numbers reach into the trillions. They form the foundation that feeds the entire ocean. From space, the bloom looks like green clouds drifting beneath the sea. A single bloom can cover an area the size of an entire country. The Southern Ocean is breathing and awakening. Phytoplankton draws in krill, tiny creatures only a few centimeters long. Yet they appear in unimaginable numbers, reaching 500 million tons across the Southern Ocean. Krill is the heartbeat of this ecosystem. Each krill weighs less than 2 grams, no bigger than a child's little finger. Yet they gather in swarms so dense they can redden entire stretches of sea. Without krill, Antarctica would become an ocean desert. Krill swarms migrate vertically each day, rising to feed on algae at night and descending to escape predators by day. This journey is repeated millions of times every hour. They are among the greatest biological forces on Earth. They come from thousands of kilometers away, the largest animals ever to live on this planet. Blue whales can weigh more than 150 tons and stretch longer than 2 buses placed end to end. Antarctica is the feast they cross oceans to reach. Each day, an adult blue whale can swallow up to 40 million krill. Its mouth opens like a cavern, straining water through thick baleen plates. It is one of the most efficient feeding systems in the animal kingdom. This natural filter evolved over 30 million years. No teeth, no chewing, only filtering and swallowing. With every gulp, millions of tiny lives disappear. Humpback whales arrive in Antarctica with a remarkable hunting secret. They cooperate in groups, rare for animals that often live apart. Each individual takes a separate role in the encircling attack. Bubble net feeding is one of nature's most complex hunting behaviors. A lead whale circles beneath the swarm, blowing bubbles to build a wall of air. Krill panic and bunch together, and that is when the whales strike. The final strike happens in less than 2 seconds. Yet each surge upward captures thousands of krill. This perfect coordination is the collective intelligence of whales. Those long white fins resemble wings of a creature flying underwater. Humpback whales are among the farthest migrating marine mammals, traveling up to 8,000 kilometers each way. Antarctica is the final destination in their search for life. An Adelie penguin colony can hold 500,000 birds. They return to the same rocky nesting grounds year after year. Their calls rise like a city waking to life. Male Adelies offer pebbles to mates as a form of courtship. A pebble nest keeps eggs above the cold, wet ground. Every stone is valuable property, and sometimes stolen from neighboring nests. Underwater, penguins transform completely, no longer clumsy on land. They can swim at 25 kilometers per hour and dive to 150 meters. Wings no longer used for flight become perfect paddles of the sea. The chinstrap penguin is named for the black line beneath its chin like a helmet strap. They are among the noisiest Antarctic penguins. Their colonies can reach millions, strange megacities of birds. Penguin feathers are waterproof, trapping air like thermal armor. Water at -2 degrees Celsius cannot penetrate this natural defense. Beneath the surface, they move like black and white bullets. The emperor penguin is the largest penguin, nearly 1.2 meters tall and weighing up to 40 kilograms. Its orange-yellow chest and neck markings are unmistakable. It is a living symbol of endurance in extreme conditions. Emperor chicks hatch in the brutal winter, not in summer. They are kept warm on their father's feet through the first months of life. Outside may be -60 degrees Celsius, while inside the brood pouch it is +36. Once large enough, emperor chicks gather into nursery groups called creches to stay warm together. Parents return from the sea and identify their own chick by its unique call. Each chick has a voice print as distinct as a fingerprint. The leopard seal is one of Antarctica's apex predators, weighing up to 500 kilograms. Its name comes from the dark spots scattered across its silver-gray coat. Beneath the ice, it waits like a living trap. The moment a penguin enters the water, the leopard seal strikes. Its reaction is faster than the blink of an eye, reaching speeds of 40 kilometers per hour. Its success rate during pursuit is remarkably high. Despite the name, the crab-eater seal does not eat crabs. It feeds on krill and is among the greatest krill consumers in the ocean. Its teeth evolved into a perfect filtering tool, like miniature whale baleen. When the crab-eater closes its jaws, water escapes while krill remain trapped inside. It is one of the strangest dental structures in the animal kingdom. Independent evolution created a solution similar to whales, but in its own way. The Weddell seal can hold its breath for 80 minutes and dive 600 meters deep. It uses its teeth to maintain breathing holes in the ice throughout winter. It is one of the southernmost marine mammals living year-round near Antarctica. The wandering albatross can travel thousands of kilometers without landing. It harvests the wind, rising and falling in long glides, turning storms into energy. The Southern Ocean, with its fierce winds, is paradise for this bird. As the sun begins to set, it will not rise again for many months. Temperatures fall below -40 degrees Celsius, with winds reaching 200 kilometers per hour. Antarctica enters winter, the harshest long night on Earth. In winter, sea ice expands by another 19 million square kilometers each year. That is nearly twice the size of the Antarctic continent itself. It is one of the greatest physical transformations on the planet. In blizzards, male emperor penguins incubate eggs with no food. They rotate slowly through the crowd so every bird gets a turn in the warm center. This behavior is not taught. It is an instinct shaped by millions of years of evolution. In the darkness of winter, the sky answers with the southern lights. These dancing ribbons are charged particles from the sun colliding with the atmosphere. For penguins below, it is the only light in the long night. Beneath the ice, the world is entirely different from the frozen surface above. Water remains near -1.8 degrees Celsius, cold but survivable. Weddell seals move through this realm as if inside a vast cathedral of ice. Life does not stop in winter, it simply moves deeper. On the Antarctic seafloor, vividly colored creatures survive at -2 degrees Celsius. Evolution here is slow, yet stranger and more unique than anywhere else. During the 65 days of incubation, the male eats nothing at all. He survives on stored fat, losing several kilograms each week. It is the longest fasting feat of any bird on Earth. The Larsen Sea ice shelf fractured in 2017, releasing an iceberg larger than Belgium. Antarctic temperatures are rising 3 times faster than the global average. What took thousands of years to form is now disappearing within decades. The sound of collapsing ice shelves can travel for tens of kilometers. Each event may raise global sea levels by a few millimeters. Small numbers, but together they build into disaster for millions of people. Many Adelie penguin colonies on the Antarctic peninsula have declined by up to 70%. Ice melts faster than they can adapt, flooding nests before eggs hatch. The food web is also disrupted as krill decline with weakening phytoplankton blooms. Commercial harvesting of krill has risen sharply over recent decades. Krill is used for animal feed and omega-3 extraction. But removing too much krill means removing the foundation of the entire ecosystem. Whales grow thinner as krill supplies decline, with body fat reserves dropping sharply compared with 20 years ago. They must travel farther and spend more energy to feed. Blue whales once came close to extinction, and that danger has never fully disappeared. Scientists drill deep into Antarctic ice to read 800,000 years of climate history. Each layer preserves the memory of an ancient atmosphere. And for the first time in that entire record, CO2 has risen beyond 420 ppm. Antarctica has warmed by 3 degrees Celsius since the 1950s. A small number, yet for this fragile ecosystem, it marks the difference between survival and disappearance. A tipping point is approaching, and no one knows exactly when it will be crossed. These eyes know nothing of emissions or policy. They know only the need for food, warmth, and a patch of ice to stand on. Yet even these simple needs are threatened by choices made on the other side of Earth. Blue whales were hunted to the edge of extinction, with 99% of their population killed in the 20th century. Then humanity stopped, and they began to recover. It is proof that nature can heal when given the chance. In 2016, 24 nations agreed to create the world's largest marine protected area in Antarctica. More than 1.5 million square kilometers were shielded from commercial fishing. It remains one of humanity's greatest conservation victories. Krill are tiny, yet they help the whole planet breathe. Through photosynthesis and the food web, the Southern Ocean absorbs nearly 40% of global CO2. Protecting krill means protecting our own climate system. Antarctica does not need humanity to survive. But humanity needs Antarctica to regulate climate, stabilize sea levels, and preserve biodiversity. We and this frozen continent are bound together. The sun will set and winter will return. But the real question is this: when the sun rises next year, will the world below still be the same? Antarctica's future is not written here, it is written by the choices we make today. From space, Earth appears almost like a water world. A single ocean covers nearly half of the planet's surface. This is the Pacific Ocean, the largest and deepest ocean ever known to humankind. Pacific Ocean is larger than all the continents combined. From Asia to the Americas spans over 20,000 kilometers, a distance nearly enough to circle the Earth. Nothing on this planet compares to its scale. It is called Pacific, meaning peaceful. But that name only reflects the surface. Beneath this calm lies a world of intensity, chaos, and mystery far beyond human understanding. Most of the Pacific remains unexplored. We know more about the surface of the moon than the depths of this ocean. This is Earth's true final frontier, not outer space, but the ocean beneath our feet. The Pacific is not just water. It is a vast living system, regulating climate, sustaining billions of lives, generating storms, and shaping human history. The journey to understand it begins here. The Pacific is far from calm. Beneath the seafloor, massive tectonic plates are constantly shifting, colliding, and sinking beneath one another. This is the largest geological engine on Earth, operating for hundreds of millions of years. The Pacific seafloor is as complex as any land surface. Vast underwater mountain ranges stretch for thousands of kilometers. Deep, silent plains extend endlessly, and dark trenches carve deep into the earth, all hidden beneath kilometers of water. The Ring of Fire surrounding the Pacific contains about 75% of the world's active volcanoes. It is also responsible for over 90% of major earthquakes. Nowhere else on Earth is geological activity this intense and dangerous. Hundreds of volcanoes are actively erupting beneath the Pacific right now. They release molten lava, create new islands, and reshape the ocean floor over time. Fire and water coexist in a dance that has lasted for millions of years. The Mariana Trench is the deepest point on Earth, reaching nearly 11,000 meters. If Mount Everest were placed inside it, its peak would still lie more than 2 kilometers below the surface. The pressure can crush steel, yet life still exists there. Only a handful of humans have reached the bottom of the Mariana Trench, fewer than those who have walked on the moon. Each mission is a journey into the most extreme conditions life and technology can endure. This is the most alien place on our own planet. When tectonic plates shift suddenly, centuries of stored energy are released in an instant. Tsunamis form, traveling at jet-like speeds and carrying the force of millions of tons of water. The Pacific is the origin of most of the deadliest tsunamis in history. All life in the Pacific begins with organisms too small to be seen. Phytoplankton, microscopic algae, perform photosynthesis and produce more than half of the oxygen we breathe. If they disappeared, the entire ocean ecosystem would collapse within weeks. The next step in the food chain is zooplankton. tiny drifting creatures that feed on phytoplankton. Each night, they perform the largest vertical migration on Earth, rising to feed, then descending to avoid predators. This is the hidden heartbeat of the ocean. Millions of small fish gather into massive schools for protection. This is one of nature's most spectacular phenomena. Millions of individuals moving as a single organism, confusing predators through perfect synchronization. Higher in the food chain are high-speed predators like tuna and swordfish. They can reach speeds of up to 80 kilometers per hour in water, faster than many land animals. Evolution has shaped them into perfect hunting machines over millions of years. Sharks are the regulators of the ocean. For over 450 million years, they have sat at the top of the food chain, controlling populations below. When sharks disappear, rays explode in number, destroying seagrass, triggering unpredictable domino effects. The blue whale is the largest animal ever to exist on Earth, heavier than 20 elephants. Yet this giant survives by feeding on tiny krill. It is nature's greatest lesson. Everything is connected, and the greatest power depends on the smallest life forms. Orcas are the wolves of the sea, hunting in groups, possessing their own language and passing down culture through generations. They even teach their young hunting techniques over years. Their intelligence raises a question. Where is the line between instinct and culture in the ocean? At a depth of 200 meters, sunlight can no longer reach. Beyond this point begins another world, one without light, without seasons, and with temperatures hovering around 2 degrees Celsius year-round. This is the twilight zone, the boundary between the familiar world and a completely alien one. Darkness does not mean the absence of color. The deep ocean is filled with bioluminescence. Hundreds of species create their own light to hunt, communicate, or defend themselves. It is the most extraordinary light show in the universe, happening every night, unseen. Deep-sea creatures seem designed by an entirely different imagination. Transparent jellyfish stretch longer than whales, vampire squids drift with webbed arms, and red tube worms grow like forests. The deep ocean hosts a biodiversity unlike anything on land. At hydrothermal vents, superheated water at 400 degrees Celsius erupts from the ocean floor. There is no sunlight, no oxygen from photosynthesis, yet life thrives here. These organisms rely on chemical energy from sulfur, forming an ecosystem completely independent of the sun. Ecosystems at hydrothermal vents prove that life does not require sunlight to exist. This has implications beyond Earth. If life can survive in such darkness and pressure, it may also exist on ocean moons of Jupiter or Saturn, waiting to be discovered. The giant squid was a creature of legend for thousands of years, yet it was first filmed only in 2004. Weighing up to 300 kilograms and possessing the largest eyes in the animal kingdom, it is not myth, but reality. The deep sea still hides secrets like this. Every time a submersible reaches the ocean floor, new species are discovered. Scientists estimate that only about 20% of the seafloor has been mapped in detail. The remaining 80% is terra incognita, the unknown frontier of our own planet. In 1997, a U.S. underwater listening system detected a mysterious signal loud enough to be heard across the Pacific. It was named the bloop. No known organism is large enough to produce such a sound. Its true origin remains unanswered. The bloop was not alone. Julia sounds like a distant scream. Upsweep is a long rising tone lasting for hours. And slow down is a strange decelerating signal from an unknown source. The ocean has its own language, and we understand only a fraction of it. Point Nemo is the most remote location on Earth, over 2,600 kilometers from the nearest land in every direction. The closest humans are not on Earth, but aboard the International Space Station overhead. Parts of the Pacific are isolated beyond imagination. Point Nemo is also known as the spacecraft graveyard, where space agencies deliberately sink decommissioned spacecraft. It is remote enough to pose no danger to anyone. The Russian Mir station and parts of the ISS now rest on the ocean floor there. We have mapped 100% of the Moon and 98% of Mars, but only about 20% of Earth's ocean floor. In fact, we know more about Venus's surface than the Pacific seabed. Many of humanity's biggest answers may lie hidden in that darkness. Every ocean expedition is a battle against the limits of technology and nature. The deep sea does not forgive mistakes. Pressure, darkness, and total isolation push humans to the edge. Yet every discovery only leads to dozens of new questions. Since World War II, global seafood production has increased fivefold thanks to technology. Modern fishing vessels can locate and capture entire schools of fish within hours. Over 90% of large fish populations have disappeared in the past 50 years, an ecological collapse unfolding before our eyes. A temperature rise of just 1 to 2 degrees Celsius is enough to kill coral, the foundation of ecosystems that support 25% of marine fish. The Great Barrier Reef has lost over 50% of its area in just a few decades. Once gone, it can take thousands of years to recover. The Great Pacific Garbage Patch is twice the size of Texas and continues to grow every day. 8 million tons of plastic enter the ocean each year. Sea turtles mistake plastic bags for jellyfish, and whales die with kilograms of plastic in their stomachs. This is the cost nature is paying for human actions. Microplastics have infiltrated every level of the ocean food chain, from phytoplankton to blue whales. They are found in the salt we eat, the air we breathe, and even in human blood. The plastic we discard today will remain in the ocean for hundreds of years. The oceans absorb over 90% of excess heat from greenhouse effects. This is changing everything: ocean currents, fish spawning seasons, and species distribution. These changes are happening faster than any natural climate shift in the past 65 million years. Ocean currents like the AMOC, the Atlantic's climate regulator, are slowing due to freshwater from melting ice diluting ocean salinity. If they stop, northwestern Europe could cool by 5 to 10 degrees Celsius within decades. This is not science fiction. It is a real risk scientists are monitoring daily. Hundreds of millions of people depend on the Pacific for survival. Small island communities are losing fish stocks and land due to rising sea levels. For them, climate change is not statistics. It is the loss of ancestry, identity, and home. The Pacific Ocean is the planet's largest storm generator. Each year, dozens of tropical storms form across its surface, carrying energy equivalent to thousands of atomic bombs. They shape the weather of Southeast Asia, East Asia, and the western coasts of the United States. El Niño and La Niña are the Pacific's global climate controls. When El Niño occurs, Australia faces drought, Peru floods, and Southeast Asia experiences extreme heat, all triggered by changes in ocean temperature in one region of the Pacific. This is the clearest proof of the ocean's power to regulate global climate. The Pacific absorbs billions of tons of CO2 each year through phytoplankton and kelp forests, acting as the planet's second lung. Without this function, the rate of climate change would double. The ocean is not just affected by climate, it actively slows its impact. The Pacific is the world's largest trade route. Over half of global goods pass through it each year. The phone you hold, the clothes you wear, the food you eat, all likely cross the Pacific at some point in their journey to you. For thousands of years, Polynesian navigators crossed the Pacific using only stars and ocean swells. They explored this vast ocean not with machines, but with inherited knowledge and deep respect for nature. It is a relationship the modern world is slowly losing. The Pacific existed millions of years before humans and will continue long after us. But the form it takes, whether it remains diverse, alive, and capable of sustaining billions, depends on the choices we make today. Hundreds of scientists are working day and night to monitor every change in the Pacific. They map the seafloor, collect samples, track species, and measure temperatures, not out of curiosity alone, but because they know understanding is the first step toward preservation. Science is hope. The Pacific is not just an ocean. It is a living world, a vast system that keeps Earth habitable. Its mysteries exceed what we know, its power surpasses imagination, and its future now lies in our hands. For billions of years, there has been a place larger than all continents combined silently preserving life. That is the Pacific Ocean, covering nearly half of Earth's oceans. Its story does not begin with giant creatures, but with things invisible to the naked eye. Just below the surface, light begins to fade meter by meter. Yet, in this dim zone, trillions of tiny organisms are working ceaselessly. They have no familiar names, but without them, nothing could survive. Cyanobacteria, blue-green bacteria appearing 2.7 billion years ago, were the first organisms to release oxygen into Earth's atmosphere. Every breath you take now comes partly from the ocean, from these invisible organisms. They are so small that millions fit in a single drop of seawater. Each spring, when light and nutrients converge, phytoplankton explode exponentially. From space, they form vast ribbons of blue and emerald on the ocean surface. This is Earth's largest harvest, and no human farmer planted it. Next in the food chain is zooplankton, tiny organisms that work tirelessly. They eat phytoplankton, converting solar energy into flesh and protein. This is the second link, and without it, the entire ocean would collapse. Krill, small shrimp only a few centimeters long, form schools billions strong, stretching over kilometers. Their biomass surpasses that of all humans on Earth. These massive krill swarms feed the largest creatures that have ever existed. As night falls on the ocean surface, a completely different world awakens below. Hundreds of species create their own light, a phenomenon called bioluminescence. In the ocean's total darkness, this is their language, lure, and mating signal. This is the foundation, invisible but indispensable. Every large creature you will encounter on this journey depends on what has just been described. Ocean life does not begin with the great, it begins with the unimaginably small. The Great Barrier Reef, the largest architectural structure created by living organisms on Earth, stretches over 2,300 kilometers along Australia's coast. From space, it is the only biological structure visible to the naked eye. Yet its builders are so tiny you could hold them in your hand. Coral polyps, only a few millimeters long, secrete a hard calcium skeleton around their bodies. When they die, the skeleton remains, and the next generation builds on top. Layer upon layer over thousands of years, this is how a coral reef is formed. Coral reefs cover less than 1% of the ocean floor, yet they are home to over 25% of all marine species. This is the densest underwater city on the planet, with every crevice a dwelling, every coral layer a neighborhood. No architect designed it, nature did it over millions of generations. In this city, no one lives alone. Clownfish live in poisonous anemones. In return, they clean and protect their host. Coral reefs are a symphony of thousands of such relationships. complex, delicate, and with no member expendable. Parrotfish do more than eat coral, they help recreate beaches. Each parrotfish can grind and excrete hundreds of kilograms of calcium per year, forming the fine white sand you see on tropical beaches. Even feeding in the ocean is part of a larger system. But this city faces a silent crisis. When ocean temperatures rise, corals expel the symbiotic algae in their tissues, losing color and their food source. Coral bleaching is not merely loss of color, it is the cry for help of a dying city. But not all is lost. Across the Pacific, hundreds of teams of scientists are transplanting young corals onto steel frames underwater. They are trying to achieve in a few years what nature takes thousands of years to accomplish, a silent and hopeful race. Coral reefs are proof that cooperation, not competition, is the foundation of a sustainable ecosystem. Thousands of species, millions of relationships, all operating in order without any central control. This is one of the greatest wonders life has ever created. Green sea turtles have existed on Earth for 110 million years, before the dinosaurs went extinct, before the Himalayas formed. They travel thousands of kilometers across oceans, returning to the exact beach where they were born, using Earth's magnetic field. Each turtle is a living compass, carrying a map of the ocean within it. Manta rays, with wingspans up to 7 meters, glide through the ocean like unpowered aircraft. They move along ocean currents, from tropical to temperate zones, following plankton reproduction cycles. They have the largest brains among fish. It is no coincidence they choose such optimal migratory routes. Whale sharks, the largest fish in the ocean, can grow up to 12 meters but feed only on plankton and small fish. They travel tens of thousands of kilometers each year, following plankton blooms detectable from afar. The strangest thing, no one knows where they reproduce, one of the greatest mysteries of marine science. Dolphins do more than just move, they travel. They ride the bow of ships not out of fear but playful curiosity, using the ship's pressure waves to glide effortlessly. This is a rare example of an animal playing with its environment purely for joy. These creatures do not move randomly. They follow fixed routes shaped by ocean currents over millions of years. The Kuroshio Current flows from the Philippines to Japan, carrying heat, nutrients, and organisms seasonally. The ocean does not stand still. It continuously pumps itself like a living body. Every moving creature performs a function, transporting energy and nutrients from surplus areas to those in deficit. They form the ocean's transportation system, unconscious, yet more efficient than any human-built logistics network. When a species disappears, these routes collapse, and the system must rebalance itself. To hunt a school of millions of sardines, dolphins do not act alone. They coordinate. One group swims around, gradually compressing the fish into a dense ball. Another group waits to strike. No commands, no clear leader, just perfect mutual understanding developed over thousands of hours living together. Dolphins communicate through a complex sound system. Each individual has a unique signature whistle, like a personal name. They call to each other and can identify specific individuals from a distance. This is the only behavior in nature, besides humans, known to use individual identity. Blue-ringed octopuses have no backbone and no centralized brain. 2/3 of their neurons are in their arms. Yet they solve puzzles, open jars, recognize individual humans, and express preferences. This proves intelligence does not need to resemble our own. Humpback whale songs can travel thousands of kilometers underwater. Remarkably, their songs change every year, spreading from one whale to another like a cultural trend. This is the first evidence of horizontal cultural transmission in nature, not parent to offspring, but neighbor to neighbor. In Shark Bay, Australia, researchers observed mother dolphins teaching their young to use sponges as tools, a behavior passed through learning, not instinct. This is tool use and intergenerational knowledge transmission, two traits once considered unique to humans. The boundary between us and the natural world is not as clear as we think. The blue whale, the largest creature ever to exist on this planet, weighs up to 180 tons and is longer than 3 buses lined up. Its heart is as large as a small car, and its heartbeat can be heard 3 kilometers underwater. No dinosaur or creature in Earth's history has ever reached this size. And this giant survives on krill, tiny shrimp no bigger than a finger. Each day, a blue whale consumes about 4 tons of krill, equivalent to 40 million tiny creatures. This reminds us, the true power of the ocean lies not in the strongest, but in the most numerous. Even whale feces play an essential role. When whales dive deep to eat krill and resurface to breathe, they release iron and nitrogen-rich feces at the sunlit surface. This nourishes phytoplankton, increases CO2 uptake, and closes the ocean's grandest nutrient cycle. If the blue whale is the largest creature, the orca is the most powerful coordinator. They sit at the top of the food chain. No species hunts orcas, not even great white sharks. But what truly sets them apart is not their strength. It is how they use it. Orcas hunt using strategy, not pure instinct. A pod in Norway rolls herring into a bubble vortex before attacking. Another pod in Antarctica simultaneously creates waves to push seals off ice. These tactics vary between orca families and are passed down over generations as cultural traditions. In an orca pod, the oldest individual, often a postmenopausal female, holds knowledge leadership. She remembers the locations of salmon schools from decades past, guiding the pod through lean seasons. Old age in the orca world is not a burden. It is an irreplaceable asset. In just 70 years, humans have fished over 90% of the large fish species in the oceans. Bottom trawling, the most common fishing method worldwide, sweeps away all organisms and seabed structures that nature takes centuries to form. What we call harvesting is in fact destroying our own food production foundation. In the middle of the Pacific Ocean exists an unwanted eighth continent, a plastic patch 3 times the size of France. Plastic does not disappear. It breaks into microplastics, enters organisms' bodies, moves up the food chain, and ends on our plates. Every year, over 8 million tons of plastic enter the ocean, equivalent to 1 truckload per minute. Albatrosses fly thousands of kilometers to feed their chicks, and inadvertently bring back plastic fragments they mistake for food. Millions of seabirds, sea turtles, and whales die each year from ingesting or entanglement in plastic. They do not know we made this. They are merely living their lives in a changing ocean. The ocean absorbs about 30% of human-emitted CO2, and this is changing its chemistry. When CO2 dissolves in seawater, it forms carbonic acid, making the ocean increasingly acidic. Shell-forming organisms, from oysters to corals to crabs, must contend with an ocean slowly dissolving their shells. For millions living on small Pacific islands, climate change is not a future forecast. It is happening now. Rising sea levels, stronger storms, declining fish stocks. Communities that have existed for thousands of years face the threat of disappearance. They contribute least to climate change, yet bear the first and heaviest consequences. But humans are not only destroyers, they also have the ability to recognize and repair. Across the Pacific, thousands of scientists monitor, research, and advocate for what remains. This is a race between awareness and inertia, and it has not yet been decided. The Mariana Trench is nearly 11 kilometers deep, deeper than the height of Mount Everest. This is a place with no light, pressures 1,000 times that of the surface, and temperatures near freezing. Yet even here, life finds a foothold. At the bottom of the Mariana Trench, amphipods, tiny crustaceans, were found with their bodies full of microplastics. Where no human has ever set foot, where only advanced submarines can reach, plastic has arrived first. This is perhaps the most sobering reality of human impact on the ocean. Sea slugs, nudibranch, are tiny shell-less creatures, living completely exposed. Yet their bright colors serve as a warning. They absorb toxins from their prey and repurpose them as defensive weapons. Thousands of species exist, each with its own coloration and survival strategy, and we still do not fully understand any of them. At hydrothermal vents on the deep seafloor, there is no light, no photosynthesis, yet life persists via chemical synthesis. Bacteria convert sulfur into energy, feeding 2-meter tube worms, blind shrimp, and crabs. This may provide clues about how life began on Earth and how it could exist on other planets. From cyanobacteria to blue whales, each creature on this journey does not exist independently. They are nodes in a vast network, and the network is only strong if each node remains intact. We do not stand outside this network. We are part of it, whether we like it or not. The Pacific Ocean existed long before humans appeared, and it has the capacity to recover if we let it. The question is not whether the ocean needs us, but whether we are wise enough to realize that we need the ocean. For the ocean is not just a habitat for creatures. It is the beating heart of this planet, and that heartbeat depends on our choices today. From space, Earth glows with the lights of human civilization. But behind those lights lies an invisible network, flows of energy that sustain the world. And all of it converges on a single, small point on the map. This is the Strait of Hormuz, a narrow stretch of water less than 50 kilometers wide at its narrowest point. Between Iran and the Arabian Peninsula, it is the only gateway from the Persian Gulf to the open ocean. Without it, much of the world's oil cannot reach its destination. Every day, around 20 million barrels of oil, about 20% of global supply, pass through these waters. This is not just a statistic. It fuels cars, planes, power plants, powers the lives of billions. On the surface, Hormuz appears calm and peaceful. Still waters, open skies. Yet beneath that calm lies the weight of the global economy flowing through it every hour. On the horizon, massive ships line up like floating buildings. Each one longer than 3 football fields, carrying hundreds of thousands of tons of crude oil. They arrive and depart endlessly, never stopping. Japan, South Korea, India, and China, the largest economies in Asia, all depend on oil passing through Hormuz. If the strait were to close for even a week, global supply chains would fall into immediate chaos. But Hormuz is more than data and maps. It is home to thousands of people, fishermen, traders, families who have lived along these shores for generations. For them, the sea is not a shipping route. It is life itself. Beneath the strait lies an entirely different world, coral, fish, and marine life that existed long before humans discovered oil. And they are still there, living in silence beneath the massive ships above. These massive oil tankers are known as VLCCs, very large crude carriers. A single vessel can carry up to 320,000 tons of crude oil, enough to power a city of millions for months. Navigating through Hormuz is far from simple. Shipping lanes are tightly controlled, each only about 3 kilometers wide. A small mistake in darkness or fog could lead to an unpredictable disaster. More than 17,000 ships pass through Hormuz each year, nearly 50 per day. In such a narrow space, managing traffic requires near-perfect coordination between nations. The risk of oil spills is ever present. When accidents happen, oil can spread across tens of square kilometers within hours. Ecosystems may take decades to recover. After every spill, people bear the consequences. Fishermen lose their livelihoods, cleanup crews work tirelessly, and marine life often has no chance of rescue. An invisible threat is underwater noise. Ship engines generate powerful sound, disrupting how dolphins and whales communicate and navigate. Beyond oil spills, ships emit large amounts of CO2 and sulfur. Global shipping accounts for about 2.5% of emissions, and Orcas is one of the most concentrated points on Earth. Beyond economics, there is a geopolitical dimension. Orcas is a zone of tension where multiple powers, including the United States, Iran, and Gulf nations, maintain military presence. Every diplomatic conflict carries real risks for maritime safety. Even a single news report about tension in Orcas can move global oil prices. In 2019, attacks on tankers near the Strait caused prices to spike within hours, affecting fuel costs worldwide. At night, Orcas never sleeps. Ships glow like moving islands across the dark water, never stopping. Because the world's demand for energy never stops. But look beneath the surface. Near Hengam Island, not far from major oil shipping routes, an entirely different world exists. Colorful corals, parrotfish, butterfly fish, a vibrant reef thriving in one of the most strategic seas on Earth. Dolphins still swim freely here, a beautiful yet heartbreaking sight beside massive oil tankers. Unaware, they live in one of the most polluted and dangerous marine environments on the planet. Sea turtles still return here to nest on white sandy beaches. They have survived millions of years of evolution. But now, they must adapt to an ocean changing faster than ever before. Scientists are monitoring every rise in sea temperature. The Persian Gulf is already one of the hottest marine regions on Earth, and it continues to warm. Coral bleaching occurs when waters become too warm, causing corals to lose their color and slowly die. When corals disappear, entire ecosystems that depend on them collapse. Less visible than coral reefs, but equally important, are seagrass meadows, breeding grounds for hundreds of fish species. They absorb carbon more efficiently than forests, yet they are rapidly disappearing. Dugongs once thrived in these waters, feeding on seagrass. Today, their numbers have declined drastically. As seagrass disappears, so do they. Seabirds still return, but fish are becoming scarce. Nature adapts, but only within limits. Everything is connected. When plankton shifts, the entire food chain is affected, from small fish to humans. On one side, a scientist studying fragile ecosystems. On the other, a massive oil tanker. Two worlds, two priorities sharing the same sea. Ahmed has fished these waters for over 40 years. His hands are rough, his eyes trained on the horizon. He knows the sea like the back of his hand, its currents, its winds, its changing seasons. But the sea he knows is changing. Massive oil tankers create waves that can overturn small boats. Engine noise drives fish away. And sometimes, thin oil slicks drift across the surface, signs of incidents never reported. Fish catches have dropped significantly compared to 20 years ago. Fishermen must travel farther, stay longer at sea, and return with far less. Every evening, women and children wait on the shore for boats to return. The sea sustains them, but it can also take everything. Every journey is a gamble. The younger generation stands at a crossroads. Fishing no longer provides enough to support a family. Many have left the trade, seeking work in industrial zones or moving to cities. A centuries-old tradition is slowly fading. This is not the first time Ahmed has pulled up nets coated in oil. They must be cleaned for hours, sometimes thrown away. The loss is real, yet no one is held accountable. From above, the village appears almost invisible beside massive passing tankers. A stark image of imbalance between local communities and global energy systems. For fishermen, the sea is not a resource or a route. It is a relationship, a long-standing bond between people and nature. And that bond is slowly being broken. Imagine the global energy and trade network as a complex circulatory system. In that system, Hormuz is the valve where all flows must pass. If that valve shuts, the entire system stops. Thousands of kilometers away, trading floors in New York, London, and Singapore react instantly to events in Hormuz. Financial markets and this distant sea beat in the same rhythm. For Gulf nations such as Saudi Arabia, the UAE, Kuwait, and Iraq, Hormuz is a lifeline. It is the only route to export oil, the foundation of their entire economies. Alternative routes exist, such as pipelines across the desert. But their combined capacity handles only a fraction of the flow. There is no true replacement for Orcas. This is why Orcas is always present in international negotiations. Every energy agreement, every nuclear talk with Iran, every military arrangement carries its shadow. The question grows louder: can the world reduce its dependence on Orcas? Renewable energy is rising, but oil still dominates. The transition is happening, but far slower than needed. A narrow stretch of sea carries the weight of modern civilization. It is both a triumph and a vulnerability of our world. This is the defining contradiction of our time. We need energy to build civilization, yet extracting and transporting it is slowly destroying the natural foundation we depend on. Nowhere is this more visible than in Orcas. Three people, three perspectives on the same sea. A fisherman sees his livelihood fading. A scientist sees ecosystems declining. A ship captain sees an essential lifeline. All of them are right, and that is the problem. Sometimes, in rare moments, the sea returns to its natural state, quiet, vast, and free. No engines, no smoke. And in that silence, it feels like the ocean is trying to remind us of something. Orcas is more than a place. It is a question of values, economic growth versus planetary sustainability. We may avoid the question, but we cannot escape its consequences. The sun sets over the Strait of Orcas. Ships keep moving. The sea remains, sustaining the world while being pushed to its limits. The question is not whether we can protect the ocean, but whether we will choose to before it is too late. On the world map, there is a narrow strip of water less than 33 kilometers wide, so small it is easy to overlook. Yet every day, 30% of the world's oil passes through here. It is called the lifeline of civilization. Every day, around 21 million barrels of oil silently pass through here, carried by massive tankers longer than 3 football fields. They come from the oil fields of Arabia and travel to every corner of the world. There is no alternative route. The Strait of Hormuz lies between Iran and the Arabian Peninsula, a single gateway connecting the Persian Gulf to the Indian Ocean. Its full width is 33 kilometers, but the actual shipping lanes are only about 3 kilometers each way. It is one of the most closely monitored geographic spaces on Earth. Thousands of years ago, Arab traders sailed these waters, carrying spices, pearls, and silk to India. Hormuz was once an independent trading empire where sea routes converged. Its role has changed, but its importance has never diminished. The human body can survive weeks without food and days without water, but only minutes without breathing. The global economy is the same. It can endure many shocks, but it cannot survive if Hormuz is closed. That is why this place is called the throat of the world. "21 million barrels of oil. That is what the Strait of Hormuz must digest every single day. If poured into Olympic swimming pools, it would fill over 30,000 of them. No other oil transit route on Earth comes close to this scale. China is the world's largest oil importer, and much of it must pass through Hormuz. Every factory running, every car moving, every building being heated in China is tied to this narrow stretch of water. It is a geographic dependency Beijing has never been comfortable with. Japan imports over 90% of its oil through Hormuz. With no significant domestic energy and no pipeline alternatives, it relies entirely on tankers and a single strait. South Korea faces a similar reality. For both nations, Hormuz is not a choice, it is geographic destiny. If supply through Hormuz is disrupted for just a few days, global oil prices could surge by tens of % within 24 hours. And when oil rises, everything rises: transport, manufacturing, food, electricity. The global supply chain tightens like a body cut off from its blood flow. We often think of oil as fuel for cars or planes. But it is also the foundation of plastics, fertilizers, pesticides, paints, synthetic fabrics, and thousands of other products. Half the items in the room you are in contain petroleum derivatives. Hormuz doesn't just carry fuel, it carries modern industry itself. India, one of the fastest-growing economies in the world, is also increasing its dependence on Gulf oil. The Jamnagar refinery processes over 1 million barrels a day, most of it arriving through Hormuz. The prosperity of hundreds of millions of Indians is anchored to a strait thousands of nautical miles from Mumbai. The northern shore of the strait belongs to Iran, the country that controls much of this strategic waterway. From here, every passing vessel is within sight, radar range, and if necessary, missile range of Tehran. It is one of the rare geographic advantages Iran holds in the global geopolitical game. Along Iran's coastline, anti-ship missiles like Noor and Khalij-Fars are positioned on rugged mountain terrain. They can strike targets hundreds of kilometers away, and within the narrow confines of Hormuz, no vessel can escape their range. This is asymmetric warfare, low cost, high destructive impact. Iran does not rely only on exposed weapons. Inside coastal mountain ranges, underground bases carved into rockhouse fast boats, missiles, and command centers. Satellite imagery cannot fully reveal them. Conventional bombs cannot easily penetrate them. This is a hidden card Iran holds, and its adversaries know it well. A $13 billion U.S. aircraft carrier can be overwhelmed by hundreds of small speedboats worth only tens of thousands each. This is the swarm tactic Iran has practiced for decades, attacking simultaneously from all directions with speed and overwhelming numbers. In the narrow waters of Hormuz, traditional technological superiority becomes ineffective. Beneath the strait, where no human eye can see, Iran could deploy thousands of naval mines within hours. A single mine can tear open the hull of a supertanker. And once a few ships are damaged or sunk, the entire route can be shut down, not by force but by fear. It is one of the most effective psychological weapons in Hormuz. In response, the United States Navy maintains a constant military presence in the Gulf and the Strait. The Fifth Fleet, based in Bahrain, patrols 24/7, with ships, radar, and satellites tracking every movement. It is a never-ending mutual surveillance, and both sides know a single mistake could trigger disaster. What sounds like a hypothesis has already happened multiple times. In 2019, several oil tankers were attacked near Hormuz, their hulls breached and crews thrown into panic. Oil prices spiked instantly, and global financial markets trembled. Just a few attacks, without full-scale war, were enough to trigger worldwide economic anxiety. In summer, temperatures in Hormuz can exceed 50 degrees Celsius. The sea becomes a mirror reflecting intense heat, and metal surfaces on ships can burn skin on contact. Crews work in conditions nearly beyond human tolerance, while electronic systems frequently fail under extreme temperatures. From the Arabian Desert, massive sandstorms regularly sweep into the strait, reducing visibility from kilometers to zero within minutes. Navigating a 330-meter-long tanker through a 3-kilometer channel without sight is a challenge captains must face. Radar becomes the only eye, yet even it can be disrupted in the storm. Hundreds of oil tankers operating simultaneously, burning low-grade heavy fuel, create a persistent haze over the strait. Combined with high humidity from the sea and desert sand, the air becomes dense and hazardous. It is one of the most polluted marine regions on the planet. A supertanker requires 3 to 5 kilometers to come to a full stop. In Hormuz's narrow 3-kilometer shipping lane, that means there is no margin for error. Captains must make split-second decisions, relying on years of experience and nerves of steel. A single collision could sink hundreds of millions of dollars and trigger a devastating oil spill in these confined waters. At the gateway of the strait, Hormuz Island appears like a work of art from above. Vivid red soil rich in iron oxide, interwoven with streaks of white, yellow, purple, and orange. It is known as the Rainbow Island. Beneath these extraordinary colors lies a history of thousands of years, when this region was once a global trade hub. The people of Hormuz do something few places in the world can claim. They eat the earth. This red soil, rich in iron oxide and minerals known as galak, is mixed into bread, used as a seasoning, or even eaten on its own. It is not poverty, but a unique culinary tradition deeply connected to the island's unusual geology. Every morning, fishermen set out to sea on small wooden boats, following traditions passed down for centuries. And every morning, they share the water with steel giants over 300 meters long, carrying oil for the global economy. Two worlds could not be more different, yet they coexist on the same narrow stretch of water. Bandar Abbas, a city of 500,000 on the northern shore, exists because of Hormuz and lives through it. Its port is Iran's main trade gateway, where goods from around the world arrive and Iranian oil flows out. For the people here, geopolitics is not abstract. It is their jobs, their income, and their daily lives. As the sun sets behind anchored oil tankers, Hormuz reveals a breathtaking beauty, red, orange, and purple blending across the calm sea. It is a moment where grandeur and fragility coexist. The pure beauty of nature, and beneath it, the ever-present tension of geopolitics. Saudi Arabia and the UAE have built pipelines across the desert to reduce dependence on Hormuz. But their total capacity can only handle about 20% of the required oil flow. The remaining 80% has no route except the strait. And building more pipelines? It would cost hundreds of billions of dollars, take decades, and face nearly insurmountable terrain challenges. In theory, tankers could reroute around the Cape of Good Hope in Africa. But that would add thousands of nautical miles, weeks of travel, and dramatically higher costs. Oil prices would rise 10 to 15% from transport alone, and the world would need twice as many tankers. It is not impossible, just too expensive to be practical. The world is transitioning toward renewable energy, but far more slowly than headlines suggest. Oil will still dominate global energy at least until the mid-21st century. During this transition, Hormuz remains irreplaceable. Dependency does not disappear overnight, it fades gradually over decades. Experts have modeled a scenario where Hormuz is closed for just 48 hours. Within the first 6 hours, global financial markets begin to tremble. By hour 24, oil prices could exceed $200 per barrel. By 48 hours, some Asian governments may convene emergency cabinets. No war is needed, just 2 days of closure. Globalization has created unprecedented prosperity, but it has also created critical vulnerabilities. Hormuz is the clearest example. A $100 trillion global economy depends on a narrow 33-kilometer strip of water. That is not strength, it is fragility dressed as prosperity. Every oil tanker that passes safely through Hormuz is the result of a delicate balance between Iran and the United States, between Saudi Arabia and its neighbors, between geopolitical calculations and economic interests. Peace here is not luck. It is the product of constant restraint, day after day. And that restraint can break at any moment. modern civilization is built on energy, and that energy must pass through Hormuz. We have created megacities, global supply chains, and complex transport networks, all relying on the uninterrupted flow through a strait narrower than a single city. It is one of the greatest contradictions of our time. Every morning, Hormuz awakens and continues its work, quiet, unseen, yet indispensable. As long as the world needs oil and economies remain interconnected, this strait will remain a crossroads of destinies. A narrow 33-kilometer strip of water, small on the map, yet carrying the weight of an entire civilization. At the very top of the earth lies a place few humans have ever set foot on. A realm of cold, vastness, and mystery, sealed beneath ice for millions of years. This is the Arctic, one of the last untouched frontiers of our planet. From a distance, the Arctic appears empty. No people, no sound. But this is only an illusion. Beneath the silence lies a world of astonishing life. A complex ecosystem moving to its own rhythm, relentless and unbroken. Ice here is more than frozen water. It is a living force, shifting, expanding, and constantly transforming. Winter temperatures fall to -40 degrees, cold enough to freeze breath in the air. And yet, life still finds a way to survive and grow. Time in the Arctic does not move as it does elsewhere on Earth. Winter stretches into months of complete darkness, without a single ray of sunlight. Then summer arrives and light returns, unbroken, 24 hours a day. The midnight sun is one of nature's most extraordinary gifts. For weeks at a time, the sun never dips below the horizon, bathing the world in endless light. Life here has adapted to this rhythm over thousands of years of evolution. To truly understand the Arctic, we must let go of everything we know about nature in gentler lands. This is a different language, one of ice, darkness, and vast silence. Step into this world and discover the secrets it still holds. Ice in the Arctic is never still. It behaves like a living body, drifting with currents and wind. Massive sheets fracture, collide, and rise into towering ridges of ice. The groaning and thunder of breaking ice form the Arctic's constant soundtrack, both majestic and unsettling. Up close, the ice reveals itself as a work of natural art. Cracks trace perfect geometric patterns, each one a record of temperature and pressure. Frozen air bubbles beneath the surface carry samples of ancient atmospheres, preserving thousands of years of Earth's climate history. Most of an iceberg's power lies hidden beneath the surface. The origin of the phrase, just the tip of the iceberg. A towering mass may rise 50 meters above water, while extending 200 meters below. Its deep turquoise color is born from light absorbed in the depths, a beauty shaped by nature itself. From beneath the water, the underside of the ice becomes another world, light filtering through layers in shimmering blue waves. Here live countless tiny organisms, algae, crustaceans, and larvae clinging to the ice. They form the foundation of the entire Arctic food web, sustaining everything from small fish to great whales. As spring arrives, temperatures rise and the ice begins to melt, forming pools of water across its surface. Meltwater flows into narrow channels, then gathers into temporary rivers winding across the white expanse. It is a signal that summer is coming, a great awakening after months of darkness. When massive ice blocks break and collapse into the ocean, the sound echoes like thunder. Each melting fragment marks an ending and the beginning of a new journey beneath the sea. Destruction and renewal exist side by side, the eternal rhythm of the Arctic. But not all melting is part of a natural cycle. Something is changing. In just a few decades, Arctic sea ice has shrunk dramatically, faster than any model predicted. The heart of the Arctic is slowing, and we can no longer afford to ignore it. In the depths of winter darkness, the Arctic sky ignites with ribbons of color. The aurora borealis, the northern lights, moves like vast curtains drifting in a cosmic wind. It is one of the greatest natural wonders our planet can offer. Science explains the aurora as charged particles from the sun colliding with Earth's atmosphere. Colors shift with altitude and gases: green from oxygen, red from nitrogen, violet from hydrogen. Yet even with explanation, the aurora holds something beyond the reach of reason. Inuit and other Arctic peoples have lived beneath the aurora for thousands of years. To them, it is not just a physical phenomenon. It is the spirits of their ancestors dancing in the sky. These stories remind us that nature carries meanings beyond what science can fully explain. Then the darkness fades, and light returns in a way only the Arctic can create. The sun hovers at the horizon, casting a twilight that lingers for weeks. Golden light spreads across the frozen expanse, an endless afternoon, quietly breathtaking. Spring light awakens the entire Arctic ecosystem. A mother polar bear leads her newborn cubs out of their den for the first time, their eyes squinting in the brightness. Their lives begin in that moment, a new chapter in the Arctic's endless cycle. Light in the Arctic plays strange tricks, deceiving even the most experienced explorers. The phenomenon known as fata morgana creates mirages, floating castles, distant islands, ships suspended in air. For centuries, these illusions have misled travelers, turning the Arctic into a realm where reality and illusion blur. When the aurora fades, another spectacle begins. A night sky untouched by light pollution. The Milky Way stretches from horizon to horizon, billions of stars shimmering like dusted diamonds. Standing beneath it, one feels more than ever how small we are within the universe. Beneath meters of solid ice lies a world few human eyes have ever seen. The Arctic Ocean, dark, frigid, and under immense pressure, is a place where life flourishes in extraordinary ways. It is one of the richest marine regions on Earth, sustained by warmer currents from the south. In spring, as the ice recedes, sunlight floods the ocean after months of darkness. Algae bloom within days, a feast that ignites the entire food chain. Millions of fish gather into vast shoals stretching for kilometers, one of the ocean's most breathtaking spectacles. Beluga whales, often called the canaries of the sea, are true natives of the Arctic. Their white color serves not only as camouflage but also as an adaptation to extreme cold. They communicate through complex sounds that travel vast distances beneath the dark ocean. The bowhead whale is the largest animal capable of living year-round in the Arctic and among the most intelligent in the ocean. Its skull is strong enough to break through ice up to 60 centimeters thick to breathe. With lifespans exceeding 200 years, some individuals may have swum beneath ice that no longer exists today. In the dark depths of the Arctic seabed live creatures still not fully understood by science. Arctic octopuses survive near freezing temperatures, their blood containing special proteins that prevent their cells from freezing. It is a perfect example of evolution's brilliance. Life always finds a way to endure. The lion's mane jellyfish, the largest in the world, drifts through the cold Arctic seas. Its bell can exceed 2 meters, with tentacles stretching up to 30 meters, longer than a blue whale. Floating silently in the dark, it captures prey with venomous strands, like living meteors of the ocean. From beneath the ocean, the ice above becomes a second sky, a ceiling of frozen light. It is a reversed world, where above and below lose their meaning. And within this strange inversion, life finds its own balance and harmony. At the top of the Arctic food chain stands a creature perfected over millions of years, the polar bear. Weighing up to 700 kilograms, with thick fat and insulating fur, it is the apex predator of the frozen world. Yet beneath its power lies remarkable intelligence and a complex social life. The polar bear's primary hunting method demands extraordinary patience. It can wait motionless beside a breathing hole for hours. When a seal surfaces, the strike is instant, precise, decisive, final. This is survival as an art, passed from mother to cub over thousands of years. Polar bears are powerful swimmers, capable of traveling hundreds of kilometers in icy waters. For the first 2 years, a mother teaches her cub everything it needs to survive. It is a bond of care and devotion, not unlike how humans raise their young. Ringed seals are among the most vital links in the Arctic ecosystem, prey for polar bears and sustenance for many others. Their thick blubber insulates them from near-freezing waters and stores energy for winter. By maintaining multiple breathing holes, they ensure a constant escape route. Musk oxen are living remnants of the Ice Age, once roaming alongside mammoths. Their dense coat is a natural insulator, finer than cashmere and exceptionally warm. Their defensive circle formation is ancient, an instinct written deep into their DNA. Each year, caribou undertake one of the largest land migrations on Earth, hundreds of thousands traveling vast distances. Guided by ancient instinct, they move without maps or compass. The thunder of their hooves echoes across the land, a symbol of collective strength. The Arctic fox embodies perfect adaptation. White in winter, brown-gray in summer. It can endure temperatures as low as -70 degrees without shivering, its body finely tuned to conserve heat. These small creatures are powerful reminders of life's resilience. Arctic summer transforms coastal cliffs into the busiest cities on Earth. Millions of seabirds crowd every ledge, while whales, seals, and bears gather to exploit the abundance of food. It is the Arctic's great summer feast, a brief but powerful explosion of life before winter returns. The walrus, with tusks up to 1 meter long and weighing as much as 2 tons, is one of the Arctic's most imposing animals. They gather in massive herds, crowding ice and shorelines to rest and stay warm. Their tusks serve not only as weapons, but as tools for climbing, status symbols, and instruments of survival. Orcas, or killer whales, are the ocean's most intelligent predators. Even polar bears avoid them in open water. They hunt in coordinated groups, using complex strategies to surround and share prey. Orcas possess culture. Each pod has its own language and hunting techniques, passed down through generations. All of these creatures converge at a single place, the ice edge, where frozen sea meets open water. It is the Arctic's most vital ecological boundary, rich in nutrients and life. Disrupt this fragile line, and the entire ecosystem begins to collapse. A chain reaction with no clear end. This is an image no one wants to see. A polar bear stranded on a shrinking piece of ice in a vast ocean. It depends on ice to hunt, to reproduce, to survive, and that ice is vanishing faster than it can adapt. This is not the story of one animal. It is the story of an entire world collapsing. The data does not lie. The Arctic is warming 4 times faster than the rest of the planet. Average January temperatures have risen by more than 3 degrees Celsius in just 50 years. Each degree means millions of square kilometers of ice lost, species pushed to the brink, and food chains disrupted. As permafrost thaws, it releases vast amounts of methane trapped for thousands of years. Methane is up to 80 times more potent than CO2 in the short term, creating a dangerous feedback loop. It is a climate time bomb, once triggered, nearly impossible to stop. Climate change in the Arctic is not just environmental, it is a humanitarian crisis. Inuit communities are losing their homes, culture, and way of life built over thousands of years. Rising seas, shifting land, and disappearing wildlife are erasing a familiar world within a single generation. Ironically, melting ice is opening new shipping routes, cutting thousands of kilometers from global trade. Nations and corporations rush to exploit resources once locked beneath ice. The question is, are we burning our own house just to stay warm? Scientists are working tirelessly to understand what is happening. Each ice core is a page in Earth's climate history. Ancient air trapped in ice reveals the past. And the data tells a troubling story. The current rate of change has not been seen in at least 2 million years. This bear does not know where it is going. It only follows instinct, searching for what once was always there. But the ice is gone, and no one can explain why. In this moment, the silence of nature speaks louder than any human warning. But the story of the Arctic is not over, and there are those still fighting to rewrite its ending. Indigenous communities, scientists, and activists are working together, blending traditional knowledge with modern technology. They believe that if humanity created this problem, it also holds the power to solve it. Each spring, new cubs are born, curious, playful, and full of life in a world they do not yet understand. They are the embodiment of hope, life continuing despite overwhelming challenges. The question is not whether they want to survive, but whether we will give them the chance. At the far southern edge of the world, where ancient maps once ended because no one dared to explore further, a legendary ocean passage still exists today. It is known as the Drake Passage, named after the explorer Francis Drake. This is the final gateway, a fragile boundary between the human world and the forgotten frozen continent of Antarctica. Stretching around 800 kilometers, this is the shortest route connecting two of the most distant continents on Earth. Yet this narrow passage hides one of the harshest seas humanity has ever encountered. For centuries, it has been both a tempting shortcut and the final resting place of countless ships. Since the age of the first explorers, sailors have passed down terrifying stories about these waters. Many expeditions disappeared forever after attempting to cross this unforgiving passage. The Drake Passage became a symbol of the thin line between human courage and nature's limitless power. But behind this terrifying violence lies a story far greater than what the human eye can see. This is not merely a dangerous route that ships must survive. It is also a place where Earth has quietly regulated its own heartbeat for millions of years. In most oceans around the world, continents and islands act as natural barriers against powerful winds. But at this latitude, there are almost no obstacles surrounding the planet. Winds and waves can travel freely across endless distances, with nothing capable of slowing their immense strength. The westerlies blow relentlessly throughout the entire year. They gather enormous amounts of energy while circling the frozen continent of Antarctica. When these powerful winds are forced through the narrow Drake Passage, all of that accumulated force is unleashed. With nothing to stop them, waves here can build enormous energy over journeys spanning thousands of kilometers. Some waves have been recorded rising over 20 meters high, equal to a 7-story building. They can appear suddenly from seemingly calm waters and overwhelm anything in their path. Weather in the Drake Passage can change with a speed that challenges even the most experienced sailors. Multiple weather systems originating from different oceans often converge in this exact region, collide, and amplify each other. As a result, the Drake Passage becomes a true battlefield where atmospheric forces are constantly in conflict. Because of all these forces combined, no ship, no matter how advanced, can afford to underestimate these waters. Every crossing of the Drake Passage is a true test of both technology and human endurance. It is a constant reminder of nature's immense and unstoppable power. But the true main character of this story is not the winds or waves on the ocean surface. Deep beneath the ocean, a massive current silently flows across the planet, known as the Antarctic Circumpolar Current, or ACC. It is the most powerful ocean current on Earth, carrying the largest volume of water in the world's oceans. Unlike most ocean currents that are interrupted and divided by continents, the Antarctic Circumpolar Current flows continuously without interruption. It forms a complete circulation around Antarctica, like a gigantic river flowing through the ocean itself, with no beginning and no end. The Antarctic Circumpolar Current is the only ocean current on Earth that connects the 3 largest oceans: the Atlantic, Pacific, and Indian Oceans. Throughout its endless journey, it transports enormous amounts of heat, salt, and nutrients across the planet. It also carries carbon, helping the ocean absorb part of the greenhouse gases released into the atmosphere. Because of this extraordinary role, the Antarctic Circumpolar Current is considered one of Earth's most important climate-regulating systems. It directly influences ocean temperatures on a global scale, from the polar regions to the equator. Without this current, the climate system we know today would likely be completely different. As the Antarctic circumpolar current reaches the Drake Passage, it encounters a unique geographical challenge. This is the narrowest point along its entire journey around Antarctica, forcing its enormous volume of water through a confined gateway. As the current becomes compressed, its speed increases dramatically, creating intense turbulence and transforming this region into one of the harshest seas on Earth. When a ship leaves Cape Horn, it also leaves behind the final protection offered by the land. From that moment onward, nothing stands between humanity and the vast open ocean. Every wave and every gust of wind strikes directly against the small vessel surrounded by an endless sea. Sailors have given this phenomenon a unique name: the Drake Shake. The ship constantly rolls and rises with relentless waves, creating a violent motion unlike anywhere else. For anyone who experiences it, this is a journey that will remain unforgettable for a lifetime. For many passengers crossing the Drake Passage for the first time, this becomes a true physical challenge. The constant movement and endless rocking make seasickness almost unavoidable. The human body is pushed to its limits while confronting the raw power of nature. Today, modern vessels are equipped with advanced radar, satellite communication, and specialized stabilization systems. Technology has greatly improved our ability to predict and respond to danger compared with centuries ago. Yet, even with these advancements, humans still cannot completely conquer this ocean. Every captain who guides a ship through these waters understands that respect for the ocean is never unnecessary. The Drake Passage has never forgiven and never will forgive human carelessness. Yet after every violent storm, a moment of unexpected calm returns, reminding us of humanity's small place within the vast power of nature. While humans struggle against the enormous waves, another creature has discovered absolute freedom in this harsh environment. This is the albatross, a bird with a wingspan reaching more than 3 meters, one of the largest flying birds in the world. For millions of years, they have been the true masters of the skies above the Southern Ocean. Albatross uses a special flying technique called dynamic soaring, taking advantage of differences in wind speed between different layers of air. Thanks to this remarkable ability, they can travel hundreds or even thousands of kilometers while barely flapping their wings. It is a perfect example of nature's extraordinary adaptation to one of the harshest environments on Earth. Since ancient times, sailors have viewed the albatross as a trusted companion and a symbol of good fortune across dangerous seas. For humans, a storm in the open ocean is a threat that must be avoided and survived. But for the albatross, those same powerful winds are a precious source of energy that allows them to glide freely. Beyond powerful winds and giant waves, the Drake Passage is also the starting point for enormous icebergs. They break away from the vast ice shelves of Antarctica after thousands of years of accumulation and compression. From that moment, they begin a long journey drifting through the vast and turbulent ocean. Each iceberg drifts according to winds and ocean currents, following no fixed route. Hidden inside these layers of ice are thousands, even tens of thousands of years of Earth's climate history. They are frozen diaries of our planet, silently traveling across the ocean. Scientists can uncover ancient atmospheric conditions through tiny air bubbles trapped inside the ice. This valuable data helps humanity understand Earth's climate history over thousands of years. Each iceberg drifting across the ocean is essentially an unwritten chapter of the planet's history. As these massive icebergs drift into warmer waters, they begin to melt, releasing fresh water into the surrounding ocean. Changes in temperature and salinity directly affect the global ocean circulation system. And the Drake Passage is one of the places where these subtle changes can be detected most clearly and earliest. Because of its extraordinary importance, the Drake Passage has become a valuable natural laboratory for scientists. Every year, international research teams brave this harsh ocean to collect data. They come here not to conquer, but to listen to what the ocean is silently telling humanity. Scientists continuously measure ocean temperature and salinity at different depths in this region. The speed of the Antarctic circumpolar current is also carefully monitored through advanced buoy systems and satellites that transmit real-time data back to land. These are invaluable datasets that cannot be collected anywhere else on Earth. Scientists also carefully monitor ocean fronts, where water masses with different temperatures meet and influence the entire marine ecosystem. Using these valuable datasets, they track global climate changes year after year. They also evaluate the ocean's ability to absorb heat and carbon dioxide, a critical factor for the future of our planet. Many scientists often describe the Drake Passage as a silent but incredibly important pressure valve of the Earth. It regulates the circulation between the planet's largest oceans, keeping the entire system operating in balance. Through this process, it helps maintain the stable global climate conditions necessary for life. Through the Antarctic circumpolar current, enormous amounts of heat are continuously exchanged between the Atlantic, Pacific, and Indian Oceans. This endless transfer directly influences the average temperature of our entire planet. A seemingly small link in this system can create enormous effects on a global scale. The Antarctic circumpolar current does not only influence the ocean itself, but also interacts closely with the atmospheric circulation above it. Any changes in this current can trigger changes in global weather patterns, from heavy tropical rainfall to severe snowstorms in the northern hemisphere. In recent decades, scientists have observed significant changes in the Drake Passage region. Ocean temperatures have shown a gradual increase, while the speed of the current has also displayed unprecedented variations. These are important warning signals that require careful monitoring by scientists around the world. Any changes occurring in this seemingly small ocean region have the potential to spread across the entire planet. This is why the Drake Passage is considered one of the most climate-sensitive areas on Earth. a tiny point on the world map, yet carrying the weight of an entire planet. The Drake Passage is not merely one of the most dangerous sea routes known to humanity. It is also an essential and irreplaceable link in Earth's entire circulation system. It is a place where wind, water, and ice come together to write the long story of our planet's climate. The relentless westerlies, the powerful Antarctic circumpolar current, the unique underwater terrain, drifting icebergs, and an extraordinary ecosystem all converge here. Together, they create an ocean realm that is both brutally harsh and unbelievably magnificent. A place that is both a great challenge and a precious gift for those seeking to understand the ocean. Even when darkness falls, scientists continue their work tirelessly, ensuring that no valuable data is lost. Every piece of information collected today could become a crucial key to predicting the future climate of humanity. This quiet persistence represents humanity's endless effort to understand nature. Around the Drake Passage, a rich ecosystem continues to survive and thrive, perfectly adapted to this harsh environment. From giant whales and seals to vast colonies of penguins, all depend on the nutrients delivered by the Antarctic circumpolar current. Life here is the clearest evidence of the deep connection between climate, oceans, and all living creatures. The story of the Drake Passage is not simply about a dangerous ocean that must be conquered or crossed. It is a profound reminder that humanity and nature exist in a deeply connected relationship that cannot be separated. Every small action we take today can create a significant impact on the future of our planet. As humanity continues its journey of exploration, the Drake Passage remains there, silent, powerful, and waiting to be understood. It is a living laboratory of Earth, where every wave tells a story about the past and the future. And ultimately, this story is about us, and about the only home we all share. This is Antarctica, the coldest, driest, and most isolated continent on Earth. Here, temperatures plunge to unimaginable lows, violent winds can howl for days without pause, and darkness can blanket the land for months at a time. Yet beneath this seemingly lifeless shell of ice lies a world bursting with extraordinary life. Towering icebergs drift silently across the Southern Ocean like forgotten frozen cities. They are formed from thousands of years of compacted snowfall before breaking away from massive ice shelves. For countless Antarctic creatures, these floating giants serve as both shelter and the fragile boundary between life and death. Antarctica does not experience the 4 familiar seasons of most of the world. Instead, it alternates between endless summer daylight and months of uninterrupted winter darkness. This dramatic cycle governs the lives of every creature that calls the frozen continent home. As summer arrives, the sun shines around the clock without ever dipping below the horizon. This endless daylight fuels explosive blooms of microscopic phytoplankton, turning vast stretches of ocean into a sea of life. These tiny organisms form the very foundation of Antarctica's entire ecosystem. Fed by abundant phytoplankton, billions of Antarctic krill flourish each summer. They gather into immense swarms so dense they can sometimes be seen from the air. Though only a few centimeters long, these tiny crustaceans sustain nearly every major animal in Antarctica. With the arrival of the brief Antarctic summer, Adelie penguins return to their traditional breeding grounds. They travel long distances from the sea to rocky nesting sites used by countless generations before them. It is an ancient journey repeated year after year. The journey is filled with danger. Deep ice cracks, slippery slopes, and biting cold test every step they take. Yet driven by instinct and the need to reproduce, these determined birds press onward without hesitation. On land, they may appear awkward, but underwater they become extraordinary swimmers. Their wings have evolved into powerful flippers, allowing them to chase krill and small fish with remarkable speed and agility. The food they gather now will determine the success of the breeding season ahead. Yet the Southern Ocean offers more than food. Beneath the icy surface, silent predators watch every movement with patience. For a penguin, a single moment of distraction can be the difference between life and death. This is the leopard seal, one of Antarctica's most formidable predators. With its muscular body, incredible speed, and jaws lined with razor-sharp teeth, it is a constant threat to penguins and many other marine animals. In the frozen world of Antarctica, the leopard seal embodies patience, precision, and raw power. Leopard seals often ambush their prey along the edge of the sea ice, where penguins must enter the water to begin their hunt for food. Remaining almost perfectly still, they wait patiently for the ideal moment. A single lightning-fast strike is often enough to end the hunt in an instant. Surprisingly, this fierce predator sometimes displays remarkable curiosity toward humans. Leopard seals have been observed circling divers, watching them closely, and in rare cases even bringing captured prey to them. This unusual behavior remains one of Antarctica's most intriguing scientific mysteries. Hidden within Antarctica's complex food web is a small but remarkably important fish, the Antarctic silverfish. Acting as a vital link between tiny organisms and larger predators, this unassuming species helps sustain the balance of the entire ecosystem. Antarctic silverfish possess natural antifreeze proteins in their blood, allowing them to survive in water colder than the normal freezing point. They convert the energy stored in krill into food for seabirds, seals, and larger predatory fish, making them an essential link in the Southern Ocean food web. High above the Antarctic colonies, another predator waits patiently for its opportunity. Known as the pirates of the polar regions, skuas patrol penguin nesting grounds, stealing eggs or attacking vulnerable chicks. Ruthless though they may seem, they play an important role in maintaining ecological balance. In contrast to the fierce skua, the snow petrel glides gracefully through Antarctica's icy cliffs, its pure white feathers blending perfectly with the frozen landscape. This natural camouflage helps it avoid predators, making it one of the few bird species that lives year-round in Antarctica. Arctic terns complete the longest migration of any animal on Earth. Every year they travel from the Arctic to Antarctica and back again, covering tens of thousands of kilometers in pursuit of endless summer. It is one of nature's most extraordinary journeys. Summer marks the breeding season for Antarctic fur seals. Once quiet beaches quickly become crowded as hundreds or even thousands of seals gather to mate and raise their young. Their calls echo across the shoreline, announcing the arrival of a new generation. Adult males engage in fierce battles for territory and the opportunity to breed. Their powerful clashes and thunderous roars transform the icy shoreline into a dramatic arena of competition. Only the strongest individuals earn the chance to pass on their genes. While the males continue to fight, mothers quietly care for their newborn pups. They nurse, protect, and keep them warm against the harsh Antarctic environment. Through this devoted maternal care, a new generation is given its best chance to survive. Far offshore lives one of Antarctica's most mysterious marine mammals, the Ross seal. Solitary by nature and rarely seen by humans, it remains one of the least studied seal species on Earth. Its unusually large eyes make it instantly recognizable among Antarctic seals. Those oversized eyes are a remarkable adaptation to life in the deep ocean. As Ross seals dive hundreds of meters in search of fish and squid, sunlight fades into near-total darkness. In that hidden world, exceptional vision becomes the key to survival. Even more remarkable are the strange underwater calls produced by Ross seals. Their vocalizations are unlike those of any other known seal species and can travel great distances through the ocean. To this day, scientists are still trying to understand their true purpose. Eventually, the brief Antarctic summer comes to an end. The sun slips below the horizon and will not return for months. Endless darkness and bitter cold announce the arrival of the Antarctic winter. Temperatures can plunge to -60 or even -70 degrees Celsius. The ocean gradually freezes into an immense sheet of ice stretching for hundreds of kilometers. Only the most extraordinary survivors can endure these brutal conditions. At the harshest time of the year, one of nature's greatest survival stories begins. Emperor penguins are the only birds on Earth that breed during the Antarctic winter. What seems impossible has become a strategy that has allowed them to survive for millions of years. After laying her single egg, the female returns to the sea, leaving the male to care for it alone. The fragile egg is balanced carefully on his feet and protected beneath a warm brood pouch that shields it from the deadly cold. For 64 consecutive days, the males survive without eating. To withstand relentless storms and freezing temperatures, thousands gather into tightly packed huddles, sharing precious body heat in one of nature's most remarkable displays of cooperation. Within the huddle, an extraordinary system unfolds. Penguins exposed to the freezing outer edge slowly move toward the warmer center, while those inside rotate outward in turn. Through this constant exchange, the entire colony shares the burden of surviving the Antarctic winter. Day after day, the fathers grow thinner as their precious fat reserves are slowly consumed. Yet they never abandon the egg, knowing that even a brief loss of warmth could end the fragile life inside. It is one of the most moving examples of parental devotion found anywhere in the natural world. At last, the long-awaited moment arrives. As the egg begins to hatch, the mother returns from months of feeding at sea, arriving at almost the exact moment her chick enters the world. This remarkable timing marks the beginning of a new generation in the heart of the Antarctic winter. Through the unwavering devotion of both parents, a new generation of emperor penguins begins its life. These fluffy chicks will grow amid the frozen wilderness, continuing a life cycle that has endured for millions of years on Antarctica's unforgiving continent. Penguins are not the only animals challenged by the Antarctic winter. Weddell seals are among the continent's greatest survival specialists. Their lives depend on small breathing holes that connect the frozen surface to the ocean below. To keep these breathing holes from freezing shut, Weddell seals constantly scrape away the surrounding ice with their teeth. They repeat this task throughout the winter because without these openings, they would have no path back to the surface to breathe. Beneath the thick sea ice, Weddell seals can remain underwater for more than an hour while hunting fish and squid in near-total darkness. They move effortlessly through the icy depths where sunlight rarely penetrates, a hidden world that few animals can survive. After every deep dive, the seals return with remarkable precision to the same breathing hole for fresh air. Their extraordinary navigation skills and unique adaptations allow them to survive beneath the Antarctic ice year-round, even when the sun disappears for months at a time. Looking at Antarctica's ecosystem as a whole, every species is connected through a remarkably delicate food web. From microscopic phytoplankton to krill, silverfish, penguins, seals, and finally giant whales, each link plays an irreplaceable role in maintaining the balance of life. If even a single link in this food web weakens, the effects can ripple throughout the entire ecosystem. Nature has spent millions of years building this delicate balance, yet even small disruptions can place it at risk. Today, this fragile ecosystem faces one of the greatest challenges in modern history. Temperatures across Antarctica are rising faster than in many other parts of the world, causing ice to melt at unprecedented rates. These changes are transforming the habitat of countless species living at Earth's southernmost frontier. Massive ice shelves that remained stable for thousands of years are now collapsing at an unprecedented pace. As the ice breaks apart and retreats, traditional breeding grounds for penguins and seals are disappearing. These changes are disrupting the delicate balance that has sustained Antarctica's ecosystem for millennia. Warming oceans and increasing acidification are placing enormous pressure on Antarctic krill, the foundation of the region's entire food web. At the same time, commercial fishing and the spread of invasive species add even greater stress to an ecosystem that is already highly vulnerable. Scenes like this have become increasingly common in recent years. They serve as a quiet yet powerful warning of the changes unfolding at Earth's southernmost frontier. Though Antarctica may seem distant, what happens here ultimately affects the entire planet. Antarctica has never been a lifeless frozen desert. It is a thriving ecosystem where every organism, from microscopic phytoplankton to the largest whales, is connected through an intricate web of life. This remarkable balance has allowed the frozen continent to flourish for millions of years. Protecting Antarctica is about far more than preserving a distant frozen continent. It means safeguarding one of Earth's most important ecosystems and helping maintain the stability of our planet's climate. What happens at the end of the world does not stay there. It ultimately shapes the future of us all. The Pacific Ocean, the largest ocean on Earth, wider than all continents combined. It holds more than half of our planet's water. And beneath its calm surface lies a world that has never stopped breathing. Sunlight reaches only 200 meters, a thin layer above an abyss 11 kilometers deep. Below it lies eternal darkness, crushing pressure, and freezing cold. And yet, life endures, resilient, strange, and intelligent in ways we are only beginning to understand. The ocean is never still. Massive currents flow like the bloodstream of a living organism. They carry heat, nutrients, and life across the planet. Without these currents, life as we know it would not exist. It begins with the smallest, plankton, invisible to the naked eye. They produce over 50% of the oxygen we breathe. The greatest forces of life are often carried by the smallest unseen hands. Millions of years of evolution have shaped countless answers to one question: how to survive. Every species is a strategy. Every body is a masterpiece of intelligence. Listen closely, the library of life is opening. Orcas, killer whales. The name sounds ruthless, but the truth is far more complex. They are not solitary hunters. They are a society. And that society operates on an intelligence we are only beginning to understand. When hunting, orcas do not rush into chaos. They use strategy. One group drives the fish, another blocks escape, others attack in sequence. It takes years for a young orca to learn this entire system from its pod. Each pod has its own language, passed from mother to calf across generations. This is not instinct. This is culture. Orcas are among the few species known to transmit culture through learning. Orcas teach their young with techniques that demand patience and precision. They wait for the perfect moment. They understand space and terrain. Their intelligence is that of a general, strategic, patient, and collective. Orcas do not need the biggest prey or the strongest bodies. They need each other. The ocean's first lesson: true power lies in cooperation. For 100 million years, that is how long sharks have existed on this planet. They have survived 5 mass extinctions, events that wiped out most life on Earth. And their form has barely changed, because they reached perfection long ago. Sharks sense bioelectric fields, faint signals from a beating heart, muscle movement, flowing blood. Even hidden beneath the sand, prey cannot escape. This is not technology, it is instinct refined to perfection over millions of years. The great white hunts alone, no allies, no complex coordination. Every strike is the result of millions of years of biological optimization. This is the intelligence of perfection. When you are already enough, you do not need to change. At first glance, the hammerhead's strange head seems like a mistake of nature. But it is a masterpiece of design. Eyes spaced wide apart, granting nearly 360-degree vision. They can see behind without turning, always aware of everything around them. Their wide head doubles as a powerful sensory array, expanding their electroreception. They scan the ocean floor like a living metal detector. Even a stingray buried in sand meters away cannot escape detection. This is sensory intelligence, mastering the environment with unmatched awareness. The whale shark, the largest fish on Earth. A mouth as wide as a doorway, a body the size of a bus. Yet all that power is used to feed on plankton and tiny fish. They have chosen not to play the game of violence, and that choice has become a remarkably successful survival strategy. By feeding on the ocean's most abundant resource, plankton, whale sharks avoid competition almost entirely. They live quietly, without the need to chase, without the need for speed, with few natural enemies. This is the intelligence of choice, taking the path of least conflict and lasting the longest. Octopuses have no bones, no shells, no claws. The only thing they truly possess is intelligence, and a very unusual one. 2/3 of their neurons are not in the brain, but spread across their 8 arms. Each arm can act independently, sensing, deciding, and moving without waiting for the central brain. This is distributed intelligence. No single center of control, every part can act on its own. lose one arm, and the others continue as if nothing happened. Octopuses use tools, a rare trait in nature. They gather coconut shells as shelter, open jars for food, solve complex puzzles. They do not simply react, they think. A mother octopus stops eating while guarding her eggs, sometimes for months. When they hatch, she is often too weak to survive. This is intelligence through sacrifice, a behavior that looks remarkably like love. An octopus lives no more than 3 years. Yet in that brief time, it learns, adapts, creates, and feels. If it lived longer, how far could its intelligence go? A question science still cannot answer. Jellyfish have no brain, no heart, no blood, no bones. They are drifting bodies of water, so simple they barely seem like animals. And yet, they have existed for over 500 million years, longer than dinosaurs, longer than sharks, longer than trees. There is a species called Turritopsis dohrnii. When injured or aging, it can reverse its life cycle, returning to its juvenile form, starting over, growing again, then repeating the process. In theory, it can do this endlessly, a true form of biological immortality. The lesson of the jellyfish: perfection does not always come from complexity, but from simplicity. When you have nothing to lose, you are nearly impossible to destroy. This is the intelligence of minimalism, and therefore of endurance. Sea snakes do not hide. They want to be seen. Their vivid colors are a warning. My venom is far more potent than that of land cobras. This is chemical intelligence. Invest in the ultimate biological weapon, then display it as an invisible shield. Lionfish do not chase their prey. They lure it in through beauty and curiosity. Their spines carry neurotoxic venom. A single touch can paralyze. Their strategy: become dangerously beautiful and let the world walk into the trap. The leafy sea dragon is the pinnacle of natural camouflage. No predator can distinguish it from real seaweed. Its leaf-like appendages do not aid movement, but perfect its disguise. Evolution chose appearance over speed, and that choice ensured survival. In seahorses, the male carries and gives birth, a rare reversal in nature.